All right, hi again. Today we're going to actually get started with the cryptology content of our class. So I'm basically just going to talk you through some of the basics, definitions, and then we'll get started with a few of the ciphers. So I have a PowerPoint here that I'm going to share with you, and we'll do it from the beginning. There we go. Okay. So first thing we're going to talk about is some terminology. So some of you might be wondering, what is cryptology? Because we haven't really done an actual definition yet. So we say that cryptology includes the study and design of methods to hide messages and also the study of breaking those methods. So we're going to be learning in this class how some of the methods work to actually encrypt or hide the information. And also if we, let's say we're a spy and we intercept somebody's encrypted message, how can we recover the original plain text message? So I just used that word a little bit prematurely, but the message that we want to send is called the plain text. The encrypted message that we actually send is called the ciphertext. Okay, so we start with plain text, we do something to it, and it's called ciphertext. The process of what we do to it is called encryption, and that's basically hiding the information. And then decryption is the opposite of that, turning the ciphertext back into plain text. All right. So we say that a crypto system has three parts. First, we need an alphabet. In this case, or in our class for at least a good while, we're going to be using just the lowercase letters A through Z. So we're not including any capital letters, punctuation, or numbers, or any other characters. And that's partially for the purposes of simplicity. Of course, you could decide to agree on a different alphabet for other purposes. So in addition to the alphabet in our crypto system, we need an encryption algorithm, which is basically a machine or a method which turns the plain text into the ciphertext. So that's how you're hiding your message. And then the third thing that you need is a key. And a key tells you kind of what setting on the encryption algorithm you're going to use. Now, usually in a kind of secure conversation, both active participants will know the key, but they'll keep that secret so that no one else can decrypt their messages while they're trying to communicate. All right. So the first cipher we're going to do, just as an example, is called the transposition cipher. A transposition cipher hides messages by rearranging the letters. So this is easiest to do if we just do an example. So let's say I want to send you a message that says, meet me at the library. Now, of course, this message has spaces, a capital M, and a period at the end, and those kind of characters are not in our alphabet. So what we have to do is basically get rid of all those things. We're going to turn the capital M into a lowercase m, get rid of the spaces, and get rid of the period. So this is what we call our plain text now, which is meet me at the library, all lowercase, no spaces, no punctuation. All right. So it looks a little bit different than the actual message that we want to send, but we can still read it. We know what it says. All right. So we have our plain text message. We have the transposition cipher that we know we're using. We also need the key. So the key here is that we are going to decide to use rows of 6 characters each. So what that means is I'm going to take the plain text message and just start writing 6 characters across. And once I get to the 7th one, I'm going to pop down a line, just write 6 more characters, and again, 6 more characters. So I conveniently chose a message that had 18 characters, which is divisible by 6. So I get this nice box, I guess, with 3 rows and 6 columns. All right. So we haven't actually encrypted anything yet. So what we're going to do is take our plain text here. And so to encrypt the message, we're going to start at this first M, but instead of going to the right, we're going to go down and write our letters that way. So our ciphertext is going to be MAI, ETB, ETR, etc. So we'll go all the way to the end. So notice that we've basically scrambled up the letters, but we've done this in a sort of methodical way. All right. So that's nice. That's how we encrypt using the transposition cipher, but how do we decrypt? So if you and your roommate are trying to communicate and you get a message from them, how do we know how to break it? So let's say that we get this message from your roommate and you're wondering, what in the world does that say? So obviously, as I mentioned before, the two partners, or the two people, I guess, that are communicating need to have agreed on the key. So in this case, you had previously agreed that your key was going to be rows of 4 letters each. Okay. So what we're going to do is start basically rearrange this message so that we have rows of 4 letters each. Okay. But if we start writing the message, we need to know how many columns are we going to end up with, or how many, yeah. So you can count this. There's 20 letters in the message, and we're going to divide by 4 letters per row, and that tells us that we need 5 rows. Okay, so what does that mean? We're going to take our ciphertext message that we received from your roommate, and so it's BOING, and we said that we need to do 5 rows, so we're going to write that down vertically, and then once we get to the 5th one, then the next letter is U, we just start another column with that. All right, so we're going to end up with 4 columns here and 5 rows. And of course, if you read this if you read the message across, you end up with, might take a minute to figure out where the spaces go, but it says buy some milk and bagels. All right, so that's how the transposition cipher works. So just a couple things for you to think about. Do you see any pros of this method of encryption, and do you see any cons? So what's kind of good about this method, and what might be the downside to using this method to communicate? And remember, you're communicating via a public channel, so how hard might it be for somebody to determine what the secret message is that you're trying to send? All right, our next example of a cipher is the shift cipher. So in the shift cipher, we take our alphabet, which remember is the lowercase letters A through Z, and we're going to shift them over 4 places. Okay, so we have 26 letters. So the first, where it says plain here, these are your plain text letters, and then the ciphertext letters are down here. So notice we've shifted everything by 4, which means the A, if I count over 4 from that, 1, 2, 3, 4, is going to correspond to the ciphertext letter E. Likewise, the plain text letter B corresponds to a ciphertext letter of F, etc. All right, so I'm going to leave that table there. And let's encrypt the message, "We ride at noon." And again, we need to get rid of all the spaces, capital letters, punctuation, etc., and kind of condense our message down. So our plain text looks like this. All right, so how do we encrypt this? Oops, sorry. Gave it away a little bit too early. So the first plain text letter is W, so we're going to find that under the plain column, and then find the corresponding ciphertext letter, which is A. So W encrypts to A. Likewise, E is going to encrypt to I. R is a plain text letter, encrypts to V, etc. And you might want to pause here and just practice a few letters encrypting on your own to make sure you understand how that works. And I'll go ahead and reveal the ciphertext message, which looks like this. All right, so now we also want to think about how do we decrypt a message, or how do we recover the original plain text if we're using this kind of cipher. So let's say, really gotta stop pushing the button too soon. Let's say we got this message from our, I don't know, it can be roommate again, I guess. This ciphertext message. So clearly that looks like not any words. So to decrypt, we're going to do exactly the opposite. We need to find the letter G in now the ciphertext rows, which is, where's my mouse, right here. G decrypts to the plain text letter of C. Likewise, V as a ciphertext letter corresponds to R. Again, you can pause the video here, try to try to decrypt a few more letters on your own, or even practice the whole message so that you're understanding how that works. And then I'll go ahead and reveal the plain text, which is cryptology is fun, which it is. All right, so briefly, let's just talk about security. So what if an enemy stole the ciphertext before it was delivered to your friend or roommate? Would the enemy be able to decipher it? So remember, in our last example, our algorithm was the shift cipher, and our key was to shift by 4 letters. Okay, so I chose 4 letters as an example. It's not going to be 4 letters every time you use the shift cipher, but this time our key was 4 letters. All right, and then this brings up Kirchhoff's principle, which says that the security of a crypto system should be based solely on keeping the key a secret and not on keeping the algorithm for encryption secret. So basically what that means is this principle is saying that anybody in the world should be able to know what algorithm you're using, or basically what cipher. So anyone in the world could know, yes, this is encrypted using a transposition cipher, or this is encrypted using a shift cipher. And your job as a communicator using that cipher is to keep this key a secret. All right, so we want to practice more with the shift cipher. And you can see from the previous examples that we have to kind of do it 1 letter at a time. And that's not difficult, but it is kind of tedious. So we have a program that we're going to use to do this for us. I guess I'll go ahead and click on the link. This is the link here to download. Oops. Okay, I'm having some trouble with screen sharing, so I'll just let you click on that link and download it from there. But the next couple slides are just going to have you practice encrypting and decrypting. So you'll download eCrypt from that link. It just says download. And as long as you have a current version of Java, hopefully you shouldn't have any issues. So for eCrypt, you can adjust the alphabet. For our purposes, for our class, we're using the lowercase letters A through Z, so make sure that is selected. And when we're doing a shift cipher, this is actually kind of a special type of affine cipher, if you will, where the multiplicative key is 1 and the additive key is the key that is agreed upon for the shift cipher. So in our example, that was 4. All right, so I have instructions here for you to practice with encrypting that message we write at noon in eCrypt to make sure that you're understanding how to use that program. And then on Monday, when we meet as a class, we are going to practice this a little bit more with an activity and see if you can break a shift cipher. All right, so again, that was just kind of an introduction to 2 types of ciphers. I'm going to have you take a little quiz where you're just going to be kind of comparing those ciphers and thinking about them a little bit.